Welcome back, Algebra students. If you're watching this video, you survived the test. I bet that's a good feeling. Hopefully you all did well. I'm sure you did. So let's get on to Unit 2 now. It's exciting, just moving right along. So we got Unit 2, Lesson 1, called the real number line. Apparently it's not going to let me do this. The real number line? There it is. Okay. I like my little laser pointer. So, Unit 2, Lesson 1, the real number line. The objectives are to graph and compare real numbers using a number line and to find the absolute value of a number. Let's get rolling. First thing we need to know is what I mean by real number. A real number is just any number that can be represented on a number line. Okay, so if I take this number line and I put 0 here, and then I got 1, 2, 3, 4, there we go, 5. We already got -1, -2, and so forth. If it'll let me write on it. There we go. Okay. So, real number is any number that can be represented on that number line. So, what we need to know about real numbers is that the farther I go to the right, or if I go to the right over here, these are my positive numbers. And then, of course, to the left are my negativo numbers. Okay. Now, we also need to know that the farther right I go on the number line, the bigger I get. So when I move to the right, I get bigger. Okay, there are still a lot of people that mix this up, where we think that -5 is bigger than -2. Well, that's not true because it's farther to the left on the number line. Okay, so again, the farther I go to the right, the bigger I get. And again, real numbers, any number that can be represented, well, I could put a dot like right here. Okay, and that could be like -4 3/4. So that's a real number. I could put a dot like right here. That could be 1.5, could be 1.44, something like that. So real numbers are just any number that can be put on the number line. So our first example, sometimes they're going to ask you to do this. It says graph -1 4/5 and -1 7/10 on the number line. Then write two inequalities that compare the two numbers. Okay, so first I got a number line here. I'm going to go ahead and put 0 and -1 and -2. Now I want your number lines to always have arrows on the end of them because our number system never stops. It can go on and on both ways. Before we can compare numbers like this, like -1 4/5 and -1 7/10, we have to have like denominators. Okay, so this should be pretty obvious here that our like denominator is going to be 10. So I only need to rewrite this top one right here, and I need to rewrite it with the denominator out of 10. So it's going to be -1 and some amount of tenths. Okay, so I ask myself, how do I get from 5 to 10? I multiply by 2, so I got to do the same thing to the top number, and 4 times 2 gives me 8. Okay, so plot these on the number line. I got -1 and 7/10 and -1 and 8/10. Okay, and then I'll label them. -1 and 7/10. And when I label the -1 and 8/10, I'm going to use the original number it was, so it's -1 and 4/5. Okay, so let's write two inequalities that compare the two numbers. So they just want to know how to compare each other. So let's compare -1 and 4/5 to -1 and 7/10 and see how they compare. And we have to decide what inequality sign will we put in between those. Well, -1 and 4/5 is farther to the left, so that means it's less than -1 and 7/10. So that's one inequality. Then we just need to compare them the other way around. So I need to put -1 and 7/10 and -1 and 4/5. And -1 and 7/10 is farther to the right, so it is bigger. Okay, sorry about my little ringtone there. But those are my answers for that. Again, oops, don't want to slide that along. We put those in circles or in a box, something like that. So there's my two inequalities. Okay, next one. Write the following numbers in increasing order. Increasing means I want to get bigger. Okay, so I want to go from smallest to largest. We could do this with a number line, but most of us won't need to. So I got -2, 4, 0, 1.5, 1/2, and -3/2. Well, we should know that negative numbers are farther to the left on the number line, so they're smaller. So that means I need to decide which one is smaller, because I want to start with the smallest number. What's smaller, -2 or -3 halves? Well, -3 halves is the same as -1.5. Okay, so that means that -2 is farther to the left, so I'm going to start with that one. Then my next negative number would be the next smallest. Okay, so I've used these two. Now I've got 4, 0, 1.5, and 1/2. But we should know it's going to go 0, and then 1/2, and then 1.5, and then 4. And there's my answer in order from smallest to largest. Okay, could use number line on that, but most of you won't need to. Should be pretty easy. If you have questions on those ones, the negative numbers and how they go together, and putting them in order, that's a big thing you're going to have to know, so make sure you ask questions on that. Alright, let's go on to some more examples. Okay, this idea of opposites and numbers that are opposites of each other is going to be huge the farther we go along, okay, the rest of the year. So we got to make sure we understand what this means. It says the numbers 3 and -3 are opposite because each is 3 units away from the origin. Okay, so opposites are numbers that are the same distance away from the origin, but they're on opposite sides of the number line. And my origin, we should know, means 0. Okay, so here's 1, 2, 3, 4, and 5, and -1, -2, -3, -4, -5. So here's -3, +3. They're both 1, 2, 3 units away from the origin, and 1, 2, 3 units away from the origin. Okay, so that's what the definition of opposite numbers are. So you could read these as 3 and -3, or another way you need to learn how to read this number right here is as the opposite of 3. Okay, that little negative sign you're going to find out is going to mean the opposite of. Okay, when we see that a lot. So yeah, you can think of -3 as -3, but you need to also recognize that it is the opposite of 3, and that this little negative sign right here can mean the opposite of. Okay, that's going to be a key concept as we go along. So, you can read the expression right here, this one, as the opposite of A. It's not -A. Okay, it's the opposite of A. So we should not assume that this expression is a negative number. Okay, because I want to know what happens when I plug in different numbers for A. This says if A is -2, then what is, and then this is why we have to learn how to read this. This no longer says -A. This says the opposite of A. So it says if A is -2, then what is the opposite of A? Well, that answer should be 2. Okay, so again, key concept from this slide is to start thinking of numbers like this -3, start thinking of it as the opposite of 3. So that when we get to something like this, it's the opposite of A. Okay, because that gets confusing sometimes. Alright, let's go on to the next slide. It is absolutely imperative, it is very important that you know what absolute value means. Okay, so absolute value is the distance a number is from the origin. Okay, again, the origin is 0, so basically it means how far away is a number from 0. Alright, so let's say I asked you to find the absolute value of 2, or let's go the absolute value of 1. Okay, absolute value is represented with these little symbols that go around a number. They look kind of like parallel lines. That's exactly what they are. So if I want to know the absolute value of 1, I want to know how far away is 1 from the origin. How far away is 1 from 0? Alright, well, before I can do that, let's make our little number line here. And I'm not going to number the other, well, yeah, I will number the other way right now. Okay, and you should be doing this too, with neater handwriting, of course. So absolute value is the distance number is from the origin. So I want to know how far away is this 1 from 0. Well, if I travel from 0 to 1, I travel 1 space on the number line. So the absolute value of 1 is 1. Okay, let's say I want to find the absolute value of -1. I want to know how far away from 0 is -1. Well, here's -1. Okay, and even if I travel this way to get to it, okay, it is still one space away from 0. I can't move negative spaces, just like I can't travel negative feet or negative yards or negative miles. So I traveled one space to get to that, so the absolute value of negative 1 is still 1. Okay, the absolute value is always a positive number. Alright? Always a positive number. So the absolute value of 4 means how many spaces away is 4 from 0? Well, you should be able to see here. Here's 4. 1, 2, 3, 4 spaces away from 0. Absolute value negative 4. Negative 4 is 1, 2, 3, 4 spaces away from 0. Absolute value of 0 means how many spaces away is 0 from 0? Well, I don't travel anywhere, so it's just 0. Okay, that's the only time you don't get a positive number for absolute value. It's because 0 is not positive or negative. So we need to know the absolute value of a number is never negative because it's distance, and distance can't be negative. Okay, so when you want to find the absolute value of a number, just use the positive version of it. Unless it's 0, then it's just 0. Okay, in the last example it says find the values of x that make the equation true. Okay, so in this one I want to know what numbers have an absolute value of 2. Okay, so I'm going to ask myself what numbers are 2 units away from the origin, because that's what absolute value means, it's the distance from the origin. So numbers that have an absolute value of 2 are 2 spaces away from 0. Well, again, here's 0, 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3, negative 4, negative 5. Which of the numbers are 2 spaces away from 0? Well, if I start at 0, I can go 2 spaces this way, and I get to 2, so I'm going to put x equals 2. But I don't just travel right on the number line, I can also travel left. So I can move 2 spaces this way and get negative 2. Okay, so both 2 and negative 2 have an absolute value of 2. They're both 2 spaces away from 0. So this bottom of example, asking what numbers have an absolute value of negative 5? It says what numbers are negative 5 spaces away from 0? Well, on the last slide I told you the absolute value, this can never be negative. So there is no answer. So this is impossible. Or no answer. Or no solution. Okay? Something like that. One of those answers would work. Okay? Seem easy enough? Happy homeworking.